Hello everyone, welcome back to the Genomics Bootcamp. This time we continue with the TASSEL software, and well, we will talk something about the user interface as we see it now, and then also how to do a quality control or filtering with TASSEL. So we ended last time with opening the test dataset or the tutorial dataset that is provided with the TASSEL software. So I want to take a little bit of time and, well, explore a little bit what we can see on the screen. So the majority of our attention right now will be directly on the top side of the screen right now, because you see here a few radio buttons and the slider here. So basically what you see here is the genotypes. So on the top side, there are the SNPs, including the SNP positions, and left side, there are the individuals. Well, in this case, or a TASSEL has a specific naming for them. It calls them taxa. So with the slider here, you can actually go left and right in your genome and basically can explore any region at will. So we can go right at the beginning. So this is the first chromosome. That actually has, if you look here at the left side, it has 540 sites, starts from 0 to 539. Here I would mention that TASSEL starts the counting from 0. This will be relevant if you want to select the sites by the number. So it's actually a minor thing, but good to know. So this, by default, the site numbers, so these are the sequential site numbers, and the bigger numbers here are actually the base pair positions for each site. So you see different letters here with a different coloring. Well, the coloring we will explain a bit later, but what the letters mean. So if you go with the slider down, so after, well, this consists of 10 chromosomes, but if you go down here, actually these are the nucleotide coding. So the A is actually homozygous AA, the C is homozygous CC, and so on. So the R is the heterozygous AG, Y is a heterozygous CT, and so on. And then the N is unknown. And also there are options for deletions and insertions, as well as other heterozygous combinations. So this is what these letters mean. If we go to the second radio button here, and if we press it, so it says locus. Well, this is a little bit misleading, because I believe this is the chromosome number, because if you have the slider and you kind of pull it to the right side, so you see that it goes up to 1 to up to 10, which is actually the number of chromosomes. So actually it says locus here, but I believe this is actually the chromosome number if you want to see a specific chromosome, so you can do it like this. The next one is the site name, which actually is the actual SNP name for that particular column. So these are how the SNPs are called for this tutorial dataset, or sites anyway, because, well, not necessarily all of them are SNPs, but, well, in this channel we are dealing right now most of the time with SNPs, so we will concentrate on SNPs only. But anyway, so these are the actual site names or the SNP names that appear in the map file. And the fourth radio button here are the alleles. I like this selection a lot, because basically it says what is the proportion of the respective alleles. So you see here, because for example, this site is a homozygous G all the way. So this is a monomorphic SNP. And for example, just nearby, there is a C A SNP. Well, it's a bit, we cannot see it too much here. Don't know how to make this one bigger. But anyway, so you see that there is a C and the A here, and the 55% C, and the A is the minor allele with the 0.45 or 45%. And you can see similarly for all the other alleles. This setting will be quite useful, because in a bit we will do a quality control, or basically filtering according to the minor allele frequency, and we will see that some of these columns will disappear according to our setting. But before doing that, I just take one more look here to this drop-down list. So right now it says my major minor allele, which is, I believe, the default setting, but there is a bunch of other ones. And this is basically how you want to color these, well, little squares here with the genotype. So for example, if you want to highlight just heterozygous, you click there and only the heterozygous, regardless of the allele combination, is highlighted. Now you see there is a lot of homozygous here, and that's because this is plant genotype data and this is from inbred lines. So it makes sense that everything is homozygous here. But if you do, or if you use some other species as input, probably you will have much more heterozygous in your data. But now let's put back to the major minor allele and let's continue with the filtering. So with the filtering, we will do also in this graphical user interface, and there is a menu button here which says filter. Now, if you click at this, you see one perhaps unconventional thing is that these are the options probably will use, and there are 3 here which says not recommended. Now, of course, there's a question why there are things there that are not recommended, and I believe this is just for the backwards compatibility with the earlier versions. If you check actually the YouTube channel from the lab that released the TASSEL software, they have also some videos on the filtering there, but they are actually using these menu points, the sites and the site names and so on. Well, this is a new version of TASSEL. So right now I'm using 5.2, and this has some pretty neat new options, or basically all these options were merged into one. And well, it has new possibilities how to filter data or how to do quality control in genotype data. And this we will be exploring right now. So basically you can do 3 types of filtering. So you can filter according to the genotype data, so according to the SNPs, filter according to the taxa, so basically according to the individuals, and filter according to the traits or phenotypes. Right now, I don't want to do anything with traits or phenotypes, so I will skip this for now, and we will concentrate on the filtering or the quality control of the genotypes and individuals. So this is how the filtering interface looks like for the genotypes. And right away, you can notice a very helpful tab here that says help. So these are all the parameters names in the filtering options with a small description, the values that they can be used in this setting, and all the default values. So if you don't change anything, these values will be in effect. So if you go there, the first thing is the filter name. So this is just to name the filter setting, which will be then appearing into left side here so that you will see at the end. So we just say test. The second line here is already quite tricky. I mean, it's not that tricky, but it's a bit in software description, it's a bit cumbersome. So basically when you read the help here, so it says site minimum count of alleles not unknown. So what it means. So you see here that we have actually number of taxa, so meaning the number of individual genotypes, 281. And well, for each, there is a genotype here, but you see there is sometimes an N here. And then if you scroll down, well, now I cannot scroll down, but the N means actually that are unknown, so that there is not genotype. And you see also that there is, for some SNPs, it appears to be quite okay. But for example, for this SNP here, there's 1, 2, 3, 4, and so on. So more unknowns here. So the proportion of the missing alleles could be different for each SNP. And you can actually limit this with this site minimal count. And well, it's not a proportion. Well, usually this is limited by a proportion, but here it says in an exact count. So to try these things out, I always like to go into an extreme and see what happens, because, well, if you go, at least for testing purposes, to an extreme setting, you would see a big change, and then therefore you would see how these things work. So let's say that I put here 280, which means that I want 280 non-missing genotypes. So it means that maximum 1 missing should be for each SNP. And we see that we have 3091 here. And when we, well, implement this really harsh setting, and let's see what happens. So we press OK, and you see that there is 200 and somewhat SNPs remain, 296. And the common denominator of each of these remaining SNPs is that there is maximum one SNP missing. Actually, you see, this individual seems to be quite bad anyway. Actually, when it comes to filtering, it doesn't belong to this bucket right now, but you probably want to make note of this individual and then, well, delete this individual manually somehow, because it seems to have quite a lot of missing SNPs, so it's quite problematic, it seems. But anyway, so this is well, one of the ways how to use this setting, but actually not the default one. So actually, you do not want to use such a harsh settings, but I just wanted to show you what happens if you do. So if we go back, and actually one thing here that you need to click back to your original data set and then starts to filtering from there, because if you would remain here and then click filter and then try to do some other changes, it would take this well, 290 something SNPs as the starting for your next filtering step. So, and probably is not what you want, because right now we want quite a number of filtering steps implemented into this big data set at once. So actually, and if you want to avoid clicking things by mistake when you do some kind of a testing, what you can also do is just click on it and hit delete, and just says, are you sure you want to delete this node? You say yes, and then it's not there anymore. So it will not worry us anymore, and then we will not do any misclick of sorts. So we can actually delete also this, and we just go back to the beginning because we want to do more things. So right now, so we have 281. So let's say that we want to say that maximum 10% of the SNPs would be missing. That would be kind of a default value that I normally use. So let's say that we allow maximally 28 SNP missing. That would be, well, just a 10% of this 281. And that means that 281 minus 28, and that is 253. So this is the kind of missingness is solved. Now, the second thing that is normally checked for, or well, depending on, of course, what kind of analysis you do, and I talked about this multiple times in the Genomics Bootcamp videos. So it's not necessary that you do all kind of quality controls and quality checks and filtering processes all the time. So you have to be aware what kind of analysis you are doing. So by no means I'm saying that you need to fill all of these columns and just filter for everything. But this video is about just looking at all the opportunities. So we will kind of look through these steps, or these most frequently done things anyway. So here, this is about the minor allele frequency. So you see, this is the default is 0 to 1. So it's basically everything is included. So what is minor allele frequency? So the minor allele frequency is one of these numbers. So I mentioned that this will come handy, and it's indeed it does. So for example, so here there are two numbers here for example, in this SNP, so 97% G and 3% A. So here the A is, well, the minor allele, and this is 3%, or the proportion is 0.03. Let's say in this other one, so this is 68% G and 32% A. And so here again, the A is the minor allele, and this is 32%, or 0.32. So now we can actually limit what we want to have here as the minimum for the minor allele. Well, one thing I would mention here, so this is 100% C here, so there is no minor allele here, but basically whatever is the minor allele, whatever could be the minor allele, that is 0. So this is just 0.0 here. Now we want to limit these, and then let's say that we want to have the minor allele frequency at least 10%. So for this really test case, or when playing around the data, so what we want to do is we just put here 0.1, and if we press the filtering, then what will happen is well, let's try OK here. So you see that there is one thing that changed. Oh, okay, back to the alleles here. So the whatever was below 0.1 or 10% is deleted from here. So this is, we get to 2079 alleles. So actually quite a number of alleles was either totally fixed or with a very low minor allele frequency. Actually, this again makes sense here because this was from maze data, or I guess maze data, which is a lot of inbred lines, so a lot of homozygosity. So let's go back and just to talk briefly about other filtering options for the genotypes. So this is left here. So then we could do is the same way as we can limit the minimum alleles frequency, we can also limit the maximum allele frequency. If you want to limit the heterozygous proportions, you can do so again with this setting. Right now, everything is included, but if you want to limit it with a minimum or maximum count, you can do so. This checkbox here is also quite interesting. And actually, if you go to the help file, it doesn't say too much more, just that it removes minor allele SNP states. It actually removes any SNPs that would be sort of a triallelic form. So there are basically, there's a major allele and minor allele. Let's say there is a GA here. And if there would be any kind of a sequencing error or other sorts, and there would be some kind of third allele popping up here. So that if this would be indeed the case, and if you check this box, then this sets this third allele, which is most likely a genotyping error, to a missing allele. So this you can actually correct for that. And then this checkbox, actually, this is more obvious. It says remove sites with indels. So, you know, in the genotyping, it's not just about SNPs, but it could be also minor or actually also larger insertions and deletions. And then this could also appear actually in on the SNP chips as well. So if you don't want those, or if you want just SNPs and nothing else, then you can actually remove those indels just by clicking this box. Well, there are also other options here that I would just go through also in a word, but I just encourage you to try it out and see what happens. These are also quite useful sometimes. So for example, this site, if you click this drop down list to sites and it says start site 0 and site 3092. So this is basically are the which SNP you want to be included. So the 0 here, so I just also remember, as I told at the beginning, so TASSEL starts counting from 0. So this is actually the first SNP on the SNP chip or on the map file, and this is the last one. So if you want, for example, to select the first 100 SNPs, then you go from 0 to 99, because just, you know, it starts from 0. So this is the first 100 SNPs. If you want, you know, the first 500 SNPs, or if you want from I don't know, from SNP 100 and 200, then actually you can do it like this. And actually I made here a mistake, because this is 100 to 200. You just go here. So this is off by 1 again, because everything starts with 0. But anyway, so you get the logic. Basically, you can select any number or any part of the genome based on the location, or not really the location, but on the sequential number of SNPs. If you want actually the location, that is the next thing here. What you can do is, well, you can select the start chromosome, end chromosome, and then start position and end position based on the base pair position on the map file. So this is, well, you can do it also and select regions like this. Also, there is a number of possibilities here that I would perhaps explore next time, or well, maybe in some other video, because, well, this is already getting too long. But basically, what you can do is you can select SNPs based on their positions, site names, based on a bed file, and based on the chromosome and position file. So if you have a separate file with the very specific positions you want to select, you can also do so based on these. Well, you can just, with this browse, you select the file and then filter according to that. But let's say that I'm happy with this solution and we want to have 0.1 with the minor allele frequency and 0.1 with the missing SNPs, and I just hit OK. And I have my list of individuals here with the, well, 2079 surviving SNPs and all the 281 surviving individuals right now. Well, I have still all the 281 individuals here because I did not filter for any of them. This I can do with the next filtering step, and that is based on the taxa. So just make sure that you are on the file that you already filtered based on the, the SNPs, and then you say filter here and based on taxa. So this will be much shorter as the previous one. Again, here we have a help file, or basically a description with the very same logic parameter, short description, values, possible values, and the default parameters. So you can have here, the description, and also perhaps a bit longer ones for this taxa list. I will explain later on, but basically the same logic applies. So we can say filter here with the, let's say, the genotypes and taxa. That's already done. Now here the same logic applies. So the minimum proportion of size present. So this is the proportion, and which we were kind of selecting based on the columns, which now we look at the rows. So basically, what is the proportion of the SNPs that are non-missing for certain individuals? So just to clarify, I put, or there is a 0.1 here, meaning that if there is more than 10% of the SNPs missing for an individual, then that individual will be deleted. Of course, you can, well, have a different number here, 0.2, 0.3, or whatever, but well, the 10% is quite a sensible number I use quite often. Again, there is an option here if you want to limit heterozygosity, again, minimal heterozygosity and maximum heterozygosity if you want to do so. So we want to include these individuals and then go on with the filtering. Again, if you want to include or exclude specific individuals or taxa, you can do this with this well, checkbox here and this taxa list. Now, how it works, again, I don't go into details right now because, well, this video is already quite long, or actually longer than I wanted. But still, so basically you select the file here, and if you have this checkbox included, that means that whatever is the list of individuals in this taxa list, this will be included in your output dataset. If you uncheck this, that means that whatever is the list of individuals here will be excluded from the list of individuals. So this is actually something that you perhaps can play around and play with to see what happens. But for now, so basically I just selected a new file name here, or a filter name, and then I just basically want to include if there is any individuals that have more than 10% missing. I just say OK here, and actually I have a, well, warning message or a message that the genotype data is unchanged after filtering, which actually says that there is no individual that would have more than 10% missing. So the individual I highlighted earlier, it's probably not that tragic in terms of genotype counts or missing genotype counts, although I would still look at it a bit more closely. But anyway, so as for these filtering steps, we have now 281 individuals, and 2088 SNPs that remain, and this can be used for further analysis. So this was it for today for the basic filtering and quality control processes in TASSEL. Well, there are a bunch of other options, or a number of other options, as you've seen, which we might explore also in further parts in Genomics Bootcamp. But what I said also, that I encourage you to go forward yourself, and perhaps with this tutorial data, click around and see what happens if you include or exclude some of the options, or if you change some of the options or include some lists, which of course then will be also useful for your further work if you go on and work actually on your own data for your own research. But for today, this is it. I thank you very much for your time and wish you a really nice day.